Okay, now we're going to compare some numbers and expressions using greater than, less than, or equal to. So you just want to clean up both sides or one side if you can. In this example, I can't clean up 5 at all, but the square root of 25 is 5. So now I just compare 5 and 5, and they're equal. So that's all there is to it. Here, I know the square root of 16 is 4, and there was a negative in front, so this is negative 4. 4 to the 0 power, anything to the 0 power is 1, so 1 will be greater. Here, negative 2 times negative 2 is 4, and 4 is greater than 0. In number 8, I know the square root of 25 is 5. I know 9 to the 1/2 would be the square root of 9, which is 3. And then 5 is greater than 3, so I'm going to use greater than. And this means 1 to the negative 1/2 means the square root of 1, and 1 times 1 is 1, so that's why this is 1. 2 to the negative 1/2, remember that forces it into the denominator, and we put a 1 in the numerator as a holder, so 1 will be greater than 1/2, so this will be greater than. Now here it's asking you to write a square root problem whose values fit each description below. We want the answer to be between 6 and 7. Well, if I wanted 6 as a square root, that would be the square root of 36. And if I wanted 7 as a square root, that would be 49. So if I want a square root that's between those two things, I just want the square root of some number between 36 and 49. So let's say 42. You can pick any of the numbers between 36 and 49. Here, I want the same idea, but I want it to be between 10, and 10 as a square root is 100, and between 11, and 11 as a square root is 121. And I want it to be closer to 10. So I want to pick something like closer to 100, so maybe like 102. All right, this is a review where we're writing perfect squares, and this is going to be important what we use later. So I want to write the first perfect squares from 1 to 12, and what I mean the first 12 perfect squares. Well, all you're going to do is in your head is do 1 times 1. That's a perfect square. 2 times 2. That's a perfect square. 3 times 3. And you need to be able to create this list on your own. 4 times 4. 5 times 5. 6 times 6. 7 times 7. 8 times 8. 9. 10. 11. And 12. And those numbers are going to be important to what we do next. So that's something you should be able to create yourself. And these are called perfect squares because all of these numbers have a number times itself that is that number. Okay, we can find the square root and get an integer answer for all of those. Okay, so we're going to use that on the next video quite a bit, and we're going to get to the nitty-gritty in the next video.